Hello and welcome to the course on sheet metal part design with CATIA in Generative Shape Design Workspace. I'll be your instructor for the course. I'm a mechanical design engineer who has worked in automotive R&D for 6+ years, and I have worked with CATIA for 5+ years, so I have experience in using CATIA as a design tool for designing suspension and chassis components. So this course is about how to use surfacing design tools of CATIA for designing sheet metal components. So we'll be learning on how to use the CATIA Generative Shape Design Workspace, which is a very commonly used workspace for designing of sheet metal parts, plastic parts in different industries, especially in automotive and aerospace industries. We will learn how to combine operations like trim, join, sweep, and multi-sections, which are commonly used in surface designing, and how to basically arrive at the outcome which we want. Also, we will learn how to create designs based on reference geometry. So for each project, for each exercise, there will be an input, which will be the reference geometry, which are all the interface components for that bracket. And based on that, the designs of the bracket will be carried out. And finally, we will develop parametric designs. So the whole goal over here is to create parametric designs, which has controllable parameters for each and every operation, which can be tweaked to change and modify the design if small design changes are required. So here the goal is to create parametric surface designs. So we are going to create parametric surface designs which are modifiable and which are tweakable. So there will be 14 unique examples to demonstrate different workflows for the generative shape design workspace. So the main learning outcome is to develop a strong familiarity with using surface design features in designing sheet metal in CATIA. So CATIA also has a dedicated sheet metal workspace, which is a more simplified version of what we'll be learning in this. So this is a more foundational concept which can be used to design any type of sheet metal bracket, whether it's a stamping bracket or a bending bracket. So also it will include tips and tricks which will be used when designing. So while designing, we will encounter some errors or issues, and then we will also learn how to rectify them. So this course is ideal if you want to level up your skills in sheet metal design. So let's say if you're designing very simple sheet metal components, and if you want to design more complex stamping type of components, like the components which are used in body of the vehicles or in chassis of the vehicles. So those kind of components require very complex workflows of surface design. So this course covers the basics of that. Or if you are already having familiarity with solid design and you want to jump into surface design, complex surface design, then this would be a good starting point. So let's start designing with this simple project. So this is the input. So we are having a pipe which is in gray color, and that is a blue color part which is to be connected to the pipe. So we need to design a bracket which is welded to the pipe and also having a resting face at the bottom of this bracket, the blue color bracket, and also having a hole for the fastener. So the first step is we need to create a plane on which we need to sketch and then create the surface. So for that, we need to create a plane which is centrally located with respect to this bracket and this fastener. So the plane has to coincide with the axis of the fastener, and it should be perpendicular to the axis of this tube. So how to create that plane? First, we will go through a geometrical set. So we will create all of these surfaces and planes and lines, everything in this geometrical set. And we will just right click on it and go to define in work object, and then go to plane, select plane. So the option for creating planes is under the reference elements dialog box. So that is a dialog box in CATIA for reference elements, within which we need to select the plane option. And we can do this in two ways. Either we can use the offset from plane. So basically offset from plane is we have a plane which is in the same direction as what we want, and then we offset from there. So a similar plane would be a plane which is at the end of this pipe over here. This is a plane. Basically this surface forms a plane, and we offset from this plane inside such that that plane will coincide with the axis of the fastener. So for that, we need to know the distance between this face and the axis of the fastener. So let's press OK now and go to measure tool. So this is a measure tool, and select the end surface here and select the axis over here. So the distance is 200 mm. Distance is 200 mm. So the offset should be minus 200 because we are going in the opposite direction this way towards the left. So minus 200, press OK. So then we will sketch on this plane and then create the geometry. Another way is Going again to plane, selecting the drop down list and selecting parallel through point. So select parallel through point. Again, select the same reference because this is our reference based on which we are going to generate the plane. Select this as reference, and this point we will go to create point. We will right click on this, go to create point, and then under point type we need to select this circle / sphere / ellipse center. Select this, and in this selection we need to select this circle center. So this circle center indicates the axis of the fastener, and this center, with respect to this center, the plane will be placed. So if you press OK, so the plane will be located over here, which is having a center at this point, and it is perpendicular to the axis of the pipe. So using this we can now sketch. Press OK. So we will delete this, select this and delete. Now using this plane as a reference, we will create two more planes. So select again plane and select the standard option. There is an offset from plane. Select this plane. So this is the reference. And now we will enter an offset value of -25. So this will form one side face of the bracket, and the other side face of the bracket is on the other side with the same value, 25 mm, and press OK. So these two planes will form the side face of the bracket. So now we can just sketch on this plane, one of the planes. Go to sketch and start sketching something like this. Keep this as vertical. And this top line has to coincide with the bottom line of this reference bracket. So select the top line and select this line, control select, and go to coincidence, make them coincide. Next we will give some more constraints. So go to constraint and give this dimension as 40. So selected this option, selecting this line and then bottom line. We will get the dimension and then just click on it to give it 40. Press OK. And then this vertical line, so escape, this vertical line has to coincide with the center. So coincide that and press OK. And you can give one more dimension over here with respect to this vertical line. So let's give this as 45. Take this point down. So this portion will be cut off. So we will see that in the subsequent operations. So just come out of the sketch, and now we will create the surface, the first surface. So for that we need to go into shape, go into generative shape design, GSD, and then in generative shape design we need to select the fill command. So that is the fill command under surfaces. So select the fill command and select this sketch and press OK. Now we have one surface, one wall of the bracket. So now we need to create the second wall. So we just need to offset this surface by 50 mm because the distance between these two planes is 50 mm. So just use the offset command, which is the second option in surfaces. Offset command and select this surface and give a distance of 50 mm and press OK. So let's hide this body to visualize the surface. Next thing is we need to connect this edge to this edge and then this edge to this edge. So for that we will go into the option for blend. So again go to surfaces and the last option, which is blend. Select blend, select this edge of the first surface. In second curve select this second edge of the second surface and press OK. Again, go to blend, select this edge of the first surface, and for the second curve, select this edge for the second surface and press OK. So now these 4 surfaces, so this one, you can see over here in the tree, in the design tree, there is one fill, there is one offset, and there are 2 blends. So there are 4 separate surfaces. If you just control select them, and then we can just basically join them using the join command, join all the surfaces. So under operations toolbox, we have the join command. We control select all of these 4 surfaces and select join and then press OK. So we have now joined all the surfaces to create one single surface. Now the next step is to give the edge fillets. So for that, we need to go into operations, and here you can see that there is an edge fillet option. So instead of selecting this shape fillet, we will select the edge fillet. So edge fillet, select that because we will be selecting the edges. So this is the edge which we will select first, and we will give it a value of 15 mm. Let's give it a value of 15 mm so that it's smooth in the transition. And then we will select these 2 edges as well, this edge and this edge, and give that as 6 mm. So 6 mm and 15 mm edge fillet. Now as you can see, the base shape of the bracket has been created. Now there are only 2 things remaining. One is to trim off the extra surface which is inside the tube, and then create a flange from that edge. So we have to create a flange such that the bracket will rest properly onto the outer surface of the tube. So how to create the trim and then to create a flange? Let's see that. So for the trim, we need to select the extract option and extract the outer surface of the tube. So for that, go in the operations, and under the third option, there are 3 sub options there. One is boundary, one is extract, and one is multiple extract. So select extract option, extract, and select the outer surface of the tube. It will be colored green, and then press OK. So this will be a surface which has been created, extracted from the tube. Now go to the second option in operations, which is the split. So there are 2 over here, split and trim. We will select split. So select split under operations and select this surface which has to be cut, and the element which is be used for cutting that is this one. So if we just hide this body of the tube, that is a solid body of the tube, you can see over here, this portion is being cut, is being trimmed off. So this portion of the bracket is being trimmed off. Press OK. Now to create a flange to increase the resting area of the bracket onto the pipe, we need to use this curve and then use parallel curve command. So let's see what is the parallel curve command. So under wireframe, so there is this option of parallel curve, this third option under wireframe of parallel curve. Select parallel curve, or if it's not visible over here, just go down into the drop down and select parallel curve and select this curve, the curve which was trimmed, or which is a result of the trim command which we used earlier. So select this curve, and then for support, select this face or this surface, the outer extracted surface of the tube. Select that as the support, and now just give this distance. So basically what we are doing is we are creating a parallel curve of this trimmed curve on the support surface, which is the extracted outer surface of the tube. So give this a distance of -8 mm. Now the next step is to create lines. So go in wireframe and select line, this line under wireframe line. Then select this end point of this curve, this end point, and select this point. And then press OK. Next, do the same thing for the other side. Select this point and select this point and create a line and press OK. Now we need to create an extract of this edge of the surface of the bracket, and then we will be basically joining all of these curves, which are wireframe curves. Wireframe are 3D curves. Combine them and use that to trim off the portion of the tube outer surface. So let's do that. So let's go to extract, select extract, We can extract surfaces, we can extract curves as well. So we can use this extract command to extract the curve. So it shows it in green color and press OK. Now we go to join command and then we join this extract, this line and this parallel line from the tree. You can just select them. So these four are curves which we created. First one we created using parallel command, second one using the line command in wireframe, and the fourth one is the extract from the existing surface. So then press OK. So it will join all of the curves. And now we can use the split command to split the portion of the outer surface of the tube which was extracted earlier and just retain the portion of the surface within this boundary of the curve. So go to split, select this surface which has to be cut and select the cutting elements, which is this. So you can see over here only this portion has been cut from the surface. So for that you need to do other side. If you select other side, it will give you the opposite solution. So now this is what we want. This is the flange we want, and then press OK. So from that whole surface, only this portion has remained. This portion has been cut out because of this curve which we had created. This collection of curves. Now let's just bring in the original part body of the tube. So now the next step is simple. Go to symmetry. So there is a symmetry option under operations. So under the translate, there is an option for symmetry in the drop down, symmetry, and select this split surface as the element to be symmetried, and reference is the center plane which we had first created, the reference plane. So with that we are symmetrying this surface. It will go on the other side and press OK. And now we just need to join them. So this is the base surface and these are the flange surfaces. Control select 3 of them from the tree and go to join and press OK. So the next step is to give the edge fillets. So for that, let's go into the generative shape design and let's go into edge fillet. So under operations, edge fillet, and select this edge and this edge. These two edges have to be selected. And let's give it a fillet of 5 mm. 5 mm. Because we want the thickness of the bracket to be 2.5 mm. So then this 5 mm, then when we thicken it outwards, it will become 2.5 mm on the outer surface. So next thing is to thicken the surface. So to add thickness, to convert it into a solid, we need to thicken the surface. For that, we need to go into the mechanical design, part design, and go into thick surface, which is this option over here. So select this option of thick surface. So it's going to ask whether you want to keep it in a body. So for that, we need to create a separate body. Insert, go to body. We have to create a body and right click and define in work object. Then select thick surface, select this surface. Make sure the directions are towards outward directions, because the surface is on the outer surface of the tube. So the thickness has to be towards outward of the surface. So give it a thickness of 2.5 and press OK. So this is the bracket which has been thickened. Now let's bring in the interface part, the blue color part, to make sure that it's all right. So you can see over here that the top surface of the bracket is interfering with the blue color reference bracket. For that, we need to modify the sketch. So for modifying the sketch, we need to go to the first sketch which we had made. So this is the first sketch where we had made it coincident. We had made the top line coincident with the bottom surface of the blue bracket. So we will remove that coincidence constraint, remove it by selecting it and delete. And now we will just drag this line downwards and then give a constraint from the bottom surface of the blue bracket to the top line as 2.5, which is nothing but the thickness, 2.5, and adjust this 40 based on that, 40 minus 2.5. So so that this bottom line remains the same, and press OK. So now we have matched it. Now the top surface of the gray bracket which we have made is matching with the bottom surface of the blue bracket. So now we have created the solid body of the bracket. Now the next steps are to create the edge fillets over here to avoid the sharp edges. So this sharp edge and this sharp edge here, fillets have to be given, and we have to give a hole to make sure that the fastener will go in and the weld nut can be attached at the bottom. For creating the hole, let's hide this reference bracket and just sketch on this top surface of the gray color bracket which we have created. So it's not selecting this face for some reason. I don't know, generally it should. So if that's the case, then we can create a plane itself over here. So for creating a plane, we can basically create through two lines, select this line and select this line and create a plane there and sketch on that plane. Sketch on that plane, create a circle, not this big, but yeah, we'll reduce the size. So this size is 10 mm. So we need to have a clearance hole. So let's keep this as 10.2 and make sure that it is concentric with that fastener. So let's select this edge and use project it and select this over here, construction element. In under sketch tools, select construction element to make it a construction element and select this circle and coincide or make it concentric with that. So make it concentric and press OK and come out of it and use the pocket command in the part design workspace. Using the pocket command, we can create a hole and then press OK. So now if we hide this, we have a hole over here, which is diameter of 10.2. And the next step is to create the edge fillets for the solid. So under this option over here, there is the edge fillet option under part design. So select edge fillet and just select all these edges. This one, this one, this one, and this one. Let's give it 5 mm. Let's give this as 2.5. This should be fine. So this is the bracket. Let's hide the geometrical set which contains all the planes and surfaces. So this will be the solid body, the interfacing bracket, and this is the fastener. Now let's have a look at the concept design of this bracket. Now here, this is the input. So there is a pipe in the middle and there is a part, the cyan color part is having 4 mounting holes. So the idea over here is to create a bracket which will be welded to the pipe and which will be bolted to the cyan color member, which is having 4 holes as shown at an angle. So we have to design a bracket which is having the connection with the pipe such that it will be welded and which is having a mating face which is aligning with these mating face, this one and this one, so that the part can be bolted to that bracket. So the first step is to create a reference plane on which we need to sketch. We need to start sketching the surface. So for that, we will create a plane in the geometrical set. So right click on the geometrical set, define in work object, select reference elements. Under that, select the plane. Let's create an arbitrary plane from this surface of the tube to, let's say, an offset of minus 70 mm. So this should be parametric. You can change that. So we'll give it a value of 70 mm and this is the plane. Now on this plane we will sketch. So start sketching on this plane. Now we'll see the sectional view and start from this point, from the center point. You can go straight, then like this. This go straight and connect to the starting point. So we created this geometry by selecting the profile command over here in Sketcher. So starting from here, we made a horizontal line, then created the lines one by one by just clicking. And this constraint, which is parallelism between this line and this line, was automatically created. Also this constraint of horizontal and this constraint of horizontal and fixed point over here has been created. So now we need to add more constraints. One more constraint to add is this line has to be parallel with this reference line on the component to which it is being assembled to. So this line, control select both of these lines, go to constraints and give a parallelism constraint. Press OK. This line has to be perpendicular to this, so select both of them, control select perpendicularity. And this line has to be perpendicular to this, so give perpendicularity again. Next, we need to add more constraints to this sketch. So go to the dimension over here, select this dimension option, select this line and give a distance of 3 mm. Then select these two parallel lines and give a value of 42 to make it smaller. Make this line vertical and give this dimension. Let's keep it at 45. So this can move along this direction up and down. So for that we need to constrain it. So this line with respect to this point needs to have a distance of, let's say, 7 mm. So now the full sketch has been constrained. It's fully green, which means that it's fully constrained. Now the next step is to create a plane such that we can symmetry this surface on the other side. So for that we need to have a plane which is located at the center at the midpoint of the line connecting the centers of this hole and this hole. So for that we can use the wireframe commands. So let's create 2 points. So select a point definition. It should be circle. This is the circle. We create a point. Then create another point, select circle as a definition, select this point, then again select the point definition. Now we will go to the drop down and select between. So it will create a point between 2 points. So the first point is this, the second point is this, and then the ratio is 0.5. We want a midpoint. So press OK. So this is the point, which is the midpoint between the two axes. So now we will create a plane which is lying on this point and which is parallel to this plane on which we sketched. So go to plane, go to parallel through point, select parallel through point option, not offset from plane, parallel through point. Parallel through point, reference is this plane and point is this. So this is the plane with which we will symmetry, and press OK. And then go to the symmetry option under operations. Under operations, there is the symmetry option. This is symmetry. Select symmetry. And this is the element which has to be symmetried. Reference is this. And press OK. Now the next step is to create a blend between this line, these two lines, 1 and 2, and the corresponding the two lines on the other side, which are symmetry. So for that we need to create a boundary. So let's hide this sketch and let's go to the boundary option. Now that boundary option is in operations. So in operations, in the third list, that is an option for boundary. So select boundary and select this. So it will select the complete boundary. So we need to define which portion of the boundary we require for blend. So we need to select this point. This is one limit, and we need to define another limit over here. So these are the two limit points, and the direction has been reversed. So we need to reverse the direction. So we need to click on this arrow. It will reverse the direction, and this will give us this boundary which will be used for blend. Press OK. Same thing, do it on the other side. Select boundary, select this, rotate on the other side, select this edge or this point and select this point. Now the direction is right, so we have selected the boundary which we want to blend, and then press OK. So these are the two boundaries which we can blend. Now go to the blend option in the surfaces. Last option is blend. Select one boundary and select the second boundary and press OK. So now we have a blend. So now the next step is to create a cutout and create a cutout over here at this edge so that we can create a bend of the sheet metal. So for that we need to sketch on this face. So this face, so let us hide this body. So we need to sketch on this face. For that we need to create a plane, or we need to directly sketch on that surface. So go to select sketch, select that surface. Okay, it is not getting selected because it's a blend. So we can create a plane there by selecting plane from wireframe. Select plane from wireframe. Select through two lines, this line and this line. So using the two lines, you can create the plane and press OK. Go to sketch, select the plane and do the normal view so that we'll get to know where we are sketching on this face. We'll create a L-shaped sketch, vertical and horizontal line. And we will give a dimension of this line, horizontal line, from this edge as 7. And we will give this line from this edge as 7 and press OK. Now the next step is to create an extrude from this. So we will create an extrude. So extrude is in surfaces. That's the first option. So the first option under this is extrude. Select this sketch and extrude it all the way through. So this is extrude and press OK. Now the next step is to trim. Before that we need to create a symmetry of this extruded surface. So go to symmetry, select this surface, select the reference as the center plane, symmetry, and now go to the split option under operations. Under operations, this split option has to be selected. Select split. The surface to be split is this blend which was created. That is the element to be cut, and the cutting elements are these two, 1 and 2. So these two are the cutting elements and press OK. Now let's hide these two surfaces, the extrude surface and the symmetry of that extrude, and let's sketch over here. So let's make lines, two lines like this. They need to be perpendicular to each other. So control select both of them and give the perpendicularity constraint. And this line has to be parallel to this. So again go to constraints, make it parallel, drag it up, and we need to give the constraints, the dimensions. From this edge it should be 7, and from this edge it should be 7. So come out of the sketch. Now we are going to extrude this through and through. Extrude this sketch and press OK. Then go to the split command, select this face, this surface, and use this extruded surface for cutting. Similarly, select the face on the other side and use the extruded surface for cutting and press OK. So this tool surface can be hidden now. So right click and hide. Now we need to create a plane so that we can create a surface which is basically the mating surface to the body, that is the cyan color body. So we need to make this surface the mating surface. So let's hide the body, and now we'll make, so let's hide these sketches so that it's easy to visualize, and hide this boundary as well, hide and hide. Let's hide this plane also and these points. So now we will make a plane. So go to plane in wireframe, and just select this line, make normal to curve, make normal to curve plane, normal to this line, and this point has to be over here at the end point. So this is the plane on which we will be sketching. Select the plane, start the sketch, and click on this line and project it. Project the line. Now start sketching the profile. Go down, go horizontal, and go down vertically, go horizontal. Just make sure that you are working perpendicular to the sketch plane, so it will be easier to visualize. Vertical, horizontal. Just make the lines horizontal and vertical. Horizontal. This should be vertical. Right click, vertical. This distance, okay, escape. This dimension of this line from the projected line has to be 7 mm. Similarly over here, this dimension has to be 7 mm. And this line from this edge has to be 11 mm. So that's the edge of the surface, the side surface, side wall. Similarly over here, this line has to be at 11 mm. And this line, bottom line, has to coincide with this point or these 2 points, this point and this point, bottom point. So select this line and control select this point, go to constraints, coincidence, press OK. So fully constrained sketch come out. Next we need to fill this. So go to fill, select the closed profile, close contour, and press OK. So now we have the base surface for the bracket. Now all we need to do is join all of these surfaces, give the edge fillets, and create a symmetrical portion on the other side. So now we will have to join all of these surfaces. For that, we need to select all of the shown surfaces. So this fill which we recently made, this split 1, 2, and 3. So this constitutes all of the surfaces, and select join and press OK. Go to edge fillet, give this fillet first, let's give it a 20. Then we will give this as 6, fillet is 6, and also this one as 6. And now we will just symmetry this edge fillet. So go to symmetry, under operations go to symmetry. So the element which has to go for symmetry is this one, which is this whole surface, and the reference has to be one of these planes, because the coordinate system is located at the center of the pipe. So this plane is the symmetry plane. So using this plane we will create the symmetry and press OK. Next, join these two surfaces, edge fillet 3 and symmetry 3, these two other surfaces which were created. Join them using the join command and press OK. So this is one complete surface. Now we need to give a thicken command. Before that, we need to trim this with respect to the outer surface. So select extract from the operations, extract this surface of the pipe and press OK, and go to split, select the element to be cut, select the cutting element which is the outer surface of the pipe, and the inside portion will be cut. So press OK. So hide the extract surface, and now we can just give the thickness to this surface. So go to start. Before that, let's insert a body. So this is the body in which we are going to thicken. Go to start, go to mechanical design, go to part design, go to thicken, thick surface. Select this, select outside and give a thickness of 3. So this is the thickened body. Hide the geometrical set and bring in the interface part. So as you can see, the bracket is sitting nicely. It is mating with the 2 mating faces, and also it is having a good connection with the pipe. So it will be welded over here throughout for a rigid connection, and it will be bolted over here. So this is a combination of a form and bend bracket. So it is having a form here because of these 2 fillets as it is like this, and it is also having the bending area which is over here. So it is a combination of both, which gives it its functionality to be welded over here as well as being bolted over here for this kind of a geometry. So here there is a very less clearance between the fillet and this edge. It can be increased for better bendability and formability, but this is just a reference design to show the design process. Since the design is fully parametric, we can change the fillet radii, or we can increase those values which we had entered for the cutouts, 7 mm, 8 mm, 9 mm. We can go on increasing that to increase that clearance and have a better bendability of this bracket. Next, we need to create the holes, the mounting holes over here by using the pocket command, and we need to just give the fillets to all the sharp edges. So let's start creating the holes by sketching over here on this plane. Sketch on this plane and just use the holes, the existing holes, to project that. So use this, control select these holes and just project it onto the plane. Using the project command, and then go to pocket and pocket it out. Same thing on the other side. Then we can increase the size of the holes. So instead of just giving the same size, we can increase the size for the clearance hole. Then there is the edge fillet. Edge fillet. Over here, over here. Over here. And here, let's give a fillet of 10 mm. Okay, you can give it at 8 mm. We'll do the same thing for the other side as well. Press OK. So all of these fillets are in this body which we have created as a bracket. Define in work object and give more fillets over here. This one, this one, this one, and this one. Select all of them, give a fillet of, let's say, 50 to make it smooth. And you can do the same thing on this side as well by giving the projection and then making the holes. In this concept design exercise, we are going to design a bracket which will be used for mounting this green color component onto this rod rigidly. So for that, we need to design a bracket which will be welded to the rod, and it will be bolted to this green color part at these 4 holes. So for that, we can design one single bracket which is accommodating all the 4 holes, or you can design one bracket which is replicating 2 sides. So which is mounting over here in 2 holes, and then that same bracket is used over here and mount it over here in these two holes. So we will do that. Let's see how we can do that by designing a sheet metal bracket for this application. So the first thing which we need to do is, let's go into the geometrical set defined in work object, and let's start sketching on this reference face. So first we need to project these holes or these circles for the reference. Control select this geometry of the circles and select project over here, project 3D elements. Make them construction elements. And now create a rectangle. Make sure that this rectangle is not a construction element. So untick over here under sketch tools. So make a rectangle and then give the dimensions originating from this projected geometry. So select the dimensioning tool, let's zoom in, select this edge of the projected geometry and this top line. Let's give it a value of 8. Do the same thing at the bottom. The value of 8. And then at this side, give a value of 13. Then on the other side as well, let's give it a value of 12. Let's give this value as well as of 12. So these are arbitrary values just to constrain the geometry. They can be modified later also if it's not suitable, if there is any issue which is arising. So come out of the sketch and go to start, go to generative shape design, and then go to surfaces. Under surfaces, go to fill command and select the close contour and create the surface. Next we need to create the side face of the bracket. So for that we need to sketch on a plane. Let's hide this. So that plane should be perpendicular to this line and point and placed over here. So we need to create a plane over here, a plane which is normal to curve. So we have to select normal to curve option under plane type and select this edge of the surface which was created. So we'll create a plane normal to that curve and placed at a point over here. That is this end point. Select that end point. So this is the plane. Now using this plane we will be creating the geometry. So go into sketch, go into the plane. So it's better to visualize the surface which we had created by just hiding this body. So this is the surface. Make the view normal. So this line indicates the surface. So basically now we have to just create a geometry which is going down like this, like this. So creating a profile which is going to be a close contour, which is going to be the side wall of the bracket. So this point has to be connected over here, coincidence, and over here we will create a circle. So creating a circle which will be concentric to this rod. The circle is concentric to this rod. So create the concentricity constraint between the circle and the rod or curve which is taken as a reference. So concentricity, not coincidence, only concentricity, and press OK. And then give a dimension to this. Let's give it 35 and make this line. So here there is a constraint which has been created which we will delete for now. So this line has to be connected with this curve. So just select the end point of the line and select this circle and go to coincidence. Make the line coincide. Similarly over here, make the end point of that line coincide with this circle. Then this point has to coincide with this point on the surface. So this point is the point on the surface. So this point has to coincide with this so that we can create a close contour and then fill it. So it will be the side, it will form the side surface of the bracket. So these two points have to coincide. So for that, go into the constraints and select coincidence by control selecting the 2 points. So coincidence. So now we have a rough geometry. Now this portion of the circle can be trimmed off. For that, we need to go into the trim option. So the trim options are under operations. So under operations, that is this option for trim. There are different variations of the trim option. So let us use this quick trim option, which is very useful. And we have to just select that and select this geometry which we want it to be trimmed, and it will just get trimmed off. And the next thing to do is just to connect these 2 points, this point to this point, to create the closed contour. But it's very important to create the closed contour, or else we will not be able to make the fill command. I need to make sure that there is no overlapping geometry or there is no disconnection between the 2 lines or any 2 curves. So that has to be checked, because that will give up an error when we go to do the fill command. So come out and just do the usual fill command, close contour, and press OK. So this is the side wall of the bracket. And the next thing is just to symmetry this surface on the other side and then join it. So that's it. So go to operations, under operations, go to symmetry, and the plane which we'll make is a plane which is at the center of this curve. Okay, before that we need to make a plane. So go to plane, normal to curve, select this curve and make sure that the point is at the middle. So default middle and press OK. Then go to symmetry, select this surface, select this reference and symmetry. So now we have the symmetry bracket. Now the next step is to join all of these surfaces which were created separately. So first we created this fill, then this one, and then we symmetried it. So there are 3 surfaces. One is the fill 1, then fill 2, and then symmetry. So control select all of them and then go to operations and join. So join all of the surfaces and press OK to create one single surface. Now we can give the fillet. So without joining, we will not be able to give the fillet. Only after joining, only when it is a single surface, then only we can give the edge fillet. So go to edge fillet, select this edge and this edge, this edge and this edge. Let's give a fillet of, let's say, 6 mm. And then we need to trim this portion off, because there is surface inside also. So we need to trim that off. Bring in the rod, just hide this, and we need to make an extract. So for making an extract, go into this boundary and make an extract of this. Now over here, if you're selecting tangent continuity in this propagation type, then it's going to select the full surface. So if you select tangent continuity, it's going to select the whole cylindrical outer surface of the rod, and then you can press OK. So the whole surface is selected as extract, and now the only thing remaining is just to trim this off or split this using the split command, which is in operations, split command. Element to cut is this, tool, cutting tool is this. So just check which side is being cut. You can toggle this using this button, other side, and press OK. So this is the surface which has been created for the bracket. Let's hide the extract because that's just the tool body. And let's bring in the interface part. So now the only thing remaining is just to thicken it. So for that we need to create a body, insert body, go to part design, go to thick surface, select thick surface, select the surface and give a thickness of, let's say, 2.5 mm inside. Make sure that it is not overlapping with the interface part. So make the thickness towards the inside direction, not the outside direction. So this is the bracket. Now we need to just give the fillets to make sure that there are no sharp corners. And this same bracket can be moved to the other position. So if you just calculate the distance between this center, we hide the bracket for now. So if we hide this bracket, and if we are just finding the distance between this center to this center, so 100 mm. So 100 mm, this body has to be replicated and moved 100 mm to position it on the other side. So this same part will be used for mounting these two holes as well. So this is one way of doing it. We can also have a single bracket which is having all the 4 points integrated into one single bracket. So there are different concepts which can be created for this application. So this is one of the concepts. So it will be welded over here, all round weld, this side and the other side. So it will give a very rigid connection and it will be bolted in these 2 points. So we need to create the holes as well for the fasteners. Now let's quickly go through the final operations to finish this part. So on this face, we'll be sketching. So inside the body, let's sketch on this face, go to sketch, and we need to extract these 2 circles to create the hole. So for that, let us hide the bracket. Using this geometry, we can extract. So select this geometry, select control, select this geometry, the circle or semicircle over here, and extract it, make it construction element, and then just bring in the thick surface. We have hidden it, bring it back and just make a circle. So right click on this, make concentricity and create a circle. Make sure that it's not a construction element. So uncheck that and give a dimension, let's say 10.5. Similarly over here, right click on this. So select circle, right click on this, make concentricity and create the circle and then give the dimension 10.5. Just exit and create the pocket. So select the pocket command in the part design workspace and press OK. So we have the holes and the only thing remaining now is the fillet. So give this fillet. Let's give it a big one so to make it smooth. Let's give it a 20 and here as well 20 and 20. Press OK. And also over here if I give a higher fillet as compared to this height, it's going to give me an error. So I need to reduce the fillet. Let's give 5. Even 5 is too high. Let's keep it the thickness as a thickness. Let's give 3. 3 should be fine. So just hide the geometrical set. So this is the bracket. Now how to replicate this in this workspace? Of course you can do it in the assembly workspace, in the product structure workspace, by just copying the part and just moving it. But if you have to just assemble it over here inside the part design workspace, We can do this by just copy pasting this body. So we have two bodies which are having the same origin, and we can just define in work object in the second body and then use the translate command. So that is a translate command in transformation features. So we can translate it over here. If you use this translation, so it's going to ask, do you really want to keep the transformation specifications? You can say yes and select. We don't need to select the body, it's already selected. So we just need to give this transformation 100 and give the direction. So the direction of transformation or translation is this, and it's going to show an arrow. Just move this by minus 100, and we have the second bracket located at the 100 mm for the other two holes. In this exercise, we will be going through the design of a body mount bracket. So consider the scenario in which you have to design a body mount outrigger bracket, and you have the location of the body mount insulator, which is the rubber part which is having a molded plate attached to it. So this is the molded plate which is used for fastening that rubber elastomeric part, which is called as the body mount, and that has to be attached rigidly to the frame, chassis frame side member. So this is a chassis frame side member in blue color. So we need to design a bracket such that we can attach this body mount insulator to the chassis frame. So the first step will be to extract the reference surfaces, which will be important, which will be reference for our design. So let us right click on the geometrical set defined in work object, go to extract under operations, the third drop down, extract, and select the bottom face of this plate on the body mount insulator. So the bottom plate is selected, press OK. Now again select extract, select this face. We want to select the whole outer surface of the side member. For that, instead of giving it no propagation, let us give it as tangent continuity. So the propagation type is tangent continuity. We can select the whole surface and press OK. So with this, we will design the whole geometry. Let us hide the bodies. So this will be our reference surfaces. So now the first step is to create the plane. So first we need to create the plane at the mounting face. So create a plane at the mounting face by selecting plane type as through planar curve, and then select this curve. So we'll create a plane for the mounting face and then press OK. We'll start sketching on this plane. Start sketching here. So we'll make a rough profile like this first. Let's make a rough profile like this. Then we'll extract this line or project this line from the side member geometry, project it and make it construction element. And we will make these lines perpendicular to this projected line. So this line has to be perpendicular to this. So select both of them, go to constraints, give perpendicularity. This line has to be perpendicular to this. Give constraints, perpendicularity. Okay, just if it's out of position, this you can move it over here. Here, this point will be over here. So this will be the rough geometry. You can keep this as a rough geometry, and this line has to be parallel to this line. So keep it parallel, press OK. For now we will keep the sketch unconstrained so that it's free to modify. So let's come out, we will add constraints later once we finalize the other geometries. So here the concept of the design would be to create a bulge such that that bulge has more welding contact between the side member and the bracket. So we will create a bulge over here at the interface of this fill with this side member. For that we need to create sketches which are normal to this line. So one at the end, one at the start, and also one in the middle. So we'll create a sketch and then we'll make a multi-section surface to create that bulge. So let's go through that workflow. So for now, let us hide this second extract, which is the side member extract, and let us only consider this line. And let us create three planes, normal to curve, select plane, normal to curve, select this curve and create a center plane, one at the center, create another curve, another plane in normal to curve, select the same curve, and this point will be this point, the start point. Again, select plane, again this curve, and this point is this end point. So three planes, and we'll be making three sketches, and then we'll be doing a multi-section surface. So bring this back in to get the perspective. Next, we will create these sketches on these three planes. So for that, let's bring in the extract, which is the side member surface. So let us start with this plane over here. Sketch on this plane. Make it normal to sketch. And we can use an additional option of slice. So cut part by sketch plane. So if we select this, it is going to slice the whole geometry at the sketch plane. So this is useful for our purpose. So it slices at the sketch plane. Now we will make a line, something like this, a horizontal line, and then an inclined line going down. Let's keep it normal to sketch. Understand? So this line indicates the fill which has been done before, and this is the line which we are creating in this sketch, horizontal line and inclined line. So this end point of the inclined line, let it be coincident to this line of the fill. So give a coincidence constraint, and let us give a constraint of, let's say, 8 mm over here, and then come out. So this is first sketch. Similarly, we'll do the another sketch on the second plane, on the mid plane. Select sketch, select the plane. Again, slice it at the sketch plane to get a better understanding. And start sketching. Make this horizontal. Let's put normal to sketch, so we'll get an idea with respect to the earlier one. So here, as you can see, there is more height available. So we can increase this height. We can increase this height. And as you can see, there is an edge over here of the plate. So we need to have some clearance between that edge and put the point over here somewhere, so that after the fillet, it will not ride onto that butting face. So we will give this point. So this point has to be coincident with the fill surface. So give that coincidence constraint and press OK. And also we need to give a distance between the horizontal line and the fill surface. Let's give it, for now, let's say it's 12. And come out of the sketch. You can go back to the earlier sketch and just move this point a bit forward. So if you just go into the 3D view and move this point a bit forward and come out of the sketch. Now we are going to sketch the third profile. So go to the third plane and go to sketch. Again, slice at the sketch plane, rotate to get a perspective, better understand the sketch, and make normal to sketch plane, and then start sketching. Start making the horizontal line and then the inclined line. So this line has to coincide with this. Give coincidence constraint. The point has to coincide with the bottom fill surface. So give coincidence constraint between those two. And this line can be, so this can have a height of, let's say 15 mm. 15 mm should be enough. Rotate to the sketch plane. Looks okay. Come out of it. So now we have these three sketches. Next, we need to make a multi-section surface. So multi-section surface, select multi-section surface under surfaces. Select this is first section, second section, and third section, and press OK. So this is the multi-section surface which will add the bulge to the bracket, which will allow it to be welded for much higher perimeter area, and also give it the required stiffness for the durability. So we can do some improvements on this multi-section surface by giving coupling points. So go to coupling. So there are multiple tabs over here. Go to coupling. Under coupling, just go over here. Select this point. Select this point, the transition point on the sketch 1 or section 1. Then select that same point on sketch 2 and select that same point on sketch 3. So you want to couple these 3 points together so to get a very smooth transition. So press OK and we will get the result. So now it is a very smooth transition between the 3 sections. Now the next step is to trim off this portion of the fill which we had made earlier. So go to split, select this which has to be trimmed and select this as the surface with which we will be trimming it. On the other side, select the other side. We want to trim this portion off and press OK. Now the next step is to model the legs on this side as well as this side and covering the flange over here. So for that, we need to create a drafted surface. So let us bring in the sketch, the first sketch which we created, and let us create a drafted surface with respect to this sketch. So let's go to sweep, select line type, select with draft direction, select this sketch. Draft direction is nothing but this plane, and we are going to give an angle of, let's say, 10 degrees, and let's give a length of 100, and let's create a sweep which is having a draft of 10 degrees for this profile and press OK. So 100 mm is too high because we don't want that much. It should be 50 mm, should be fine to create the legs. So then this will be the base surface on which we'll be trimming and creating the legs. But there is a gap over here. For the bulge we created, for that we don't have the surface. So for that, we can just extrapolate this drafted surface upwards and then trim it off. So for that, we can just extrapolate, select the same sketch and go into extrapolate, select extrapolate option, select that same sketch and select the new drafted surface and just extrapolate it upwards. Make sure that it's curvature continuity and make sure it is going through this whole surface. So give it a value of, let's say, 25. So it's going through the whole surface. It's cutting through the multi-section surface. So now we just need to trim it off. So let's do the trimming. So the first trim which we'll be doing is this extrapolated surface has to be trimmed off. Okay, before that we need to join these two. First, let's hide the extracted bodies and let us join this split with this multi-section surface. So join them both, join these two, and now we need to trim this with respect to this. Okay, it's giving an error. So the error is because here, as you can see, the whole surface is not covered. There is a gap here. So that can be avoided by just modifying these sketches, making them longer, simple. Also modifying this, making it longer. Just need to make sure that it covers the whole surface. Then only it will be trimmed, or else it will give an error. So select this and select this. We need the bottom portion. The top portion is not required, and press OK. Then similarly, what is this? Okay, this has to be trimmed off. It's So similarly we have to do for this surface, because as you can see from these lines we need to trim off over here. So we can use this and trim it off and press OK. And now the only thing to do is to create another multi-section at the bottom to create the legs of the bracket. So let's bring in the extracted surfaces which have been used as a reference. So as you can see how it is resting on the side member. Of course we need to trim off these extra portions which are going inside the side member. Before that, let us make the multi-section surface which will be created over here, and that surface will be used for trimming this extra portion to create the legs. So we'll be using these two planes which we have already created over here for the existing multi-section surface to create the new multi-section surface at the bottom. So let us start. Let us first hide these sketches so the clutter is reduced. So hiding these sketches, and hide this sketch as well. And hide the middle plane which is not of any use right now. So sketch on this plane over here, sketch, and slice at the sketch plane, which is a very useful command in this case, and start sketching like this. Make a horizontal line, then a inclined line, then a more steeply inclined line. This is just a rough sketch. You can give some fillet radius to the sketch. Let this be 35. So under operation there is an option to give the fillet. You can give a fillet over here between these two lines. Let it be 20. And come out of the sketch. Similarly, make another sketch on this plane. Sketch, use the slice option. Normal to sketch. Start sketching like this. So let's hide the earlier sketch and let us normal to sketch view. Make a fillet here by selecting that point. Let's give it, let's say 90 mm as the radius, and this is 25. Let's extend this line and come out of the sketch. Let's bring back the earlier sketch. Go into the sketch and just extend this line as well. And come out of the sketch. Now we will make a multi-section surface between these, this and this. Press OK. So as you can see, this multi-section surface is not passing through completely this drafted surface. So we need to extrapolate. So extrapolate, select this boundary, which is the sketch. Select this surface and extrapolate completely. Press OK. Again select extrapolate, select this side sketch. Select that same surface, extrapolate. Make sure the continuity is curvature and press OK. And now we will be able to trim this portion off. So go to trim, select this surface which has to be trimmed, select this extrapolated surface which is the tool for trimming, and now we can trim this whole portion off and press OK. So this side, this will be the leg of the bracket. Let's hide the tool which is the extrapolated surface. So this will be the leg of the bracket on this side, and this will be the leg of the bracket on this side. As you can see, the side member is not at the same level on both the sides, so we had to make two separate sketches so that we can make that transition. Now we have to join all of the surfaces and give the edge fillets. So join this split surface with this split surface and select join, press OK. Let's hide this extract for now. Okay, let's keep the side member extract. Let's hide this extract. So this is a joined surface and the portion inside the side member has to be cut off. So we need to use the trim option, split option. This is the surface which has to be split and the cutting element is this. Press OK. Now let's give the edge fillets. First we'll give one over here, which is, let's keep it at 25. Okay, while doing this, we need to bring in the extract such that the edge fillet is not too high, so as to ride upon this mounting surface. And also the edge fillet over here, which we'll be giving, so that we need to have some space for that. So let's reduce this to, let's say 20. This one is, let's keep this as 30. And let's keep this edge fillet as 20. Now we need to give edge fillet over here, and then this one. So we need to give it in the proper sequence so that we can cover this edge fillet completely in one go. So we need to give it over here first, and then only on this continuous edge. So give an edge fillet over here. Let's keep it at 10. And let's give an edge fillet over here. Let's keep it at 8. And then an edge fillet covering this whole edge. Let's keep this as 7. So as you can see, this edge fillet is riding over here on top of this. So for that, we can just modify this original sketch which we had. So just move this slightly and we should be done. So yeah. So this is the parametric design of the outrigger bracket surface, which can be modified. You can change the edge fillets. Also over here, if you want to have a much more liberal fillet, we can give a variable fillet, which is an option in CATIA which can allow us to give a variable fillet over here. So if we just remove this fillet over here, if you can give a variable fillet over here. So go to this drop down, there is an option of variable fillet. So if you select this, it'll select the whole edge. Here instead of 7, if let's say if you want to give 12, press OK. And if then we can give additional points. So select on points, you can select this point. So here also if you want it to be 12, and at this point, let's say we want to transition it to be 7. So we can pick any of the point along this edge and give a value of fillet, and the fillet will transition based on those values. And press OK. So as you can see, at the mating point of the frame and the bracket, the edge fillet is higher, and over here it's smaller. So this will allow for a better forming. Formability will be improved for this bracket since the draw depth is very high. So as we increase the fillet, the formability increases. So now we can just thicken this and create the bracket. So let's go to insert, go to body, insert body, define in work object, go to mechanical design, part design, select thick surface, thicken it inside. Let's give a thickness of, let's say 2.6. So this is the thickness. Let's hide the extracted surfaces and let's bring in the bodies. Let's hide the geometrical set. So this is the bracket which has been designed. The bracket is fully parametric. So if you want to improve the clearances over here, we can just adjust the original sketches which we made by increasing the clearances or by reducing the fillets. So all the parameters can be changed by going into the various sketches and the operations. Now we will be designing a suspension mount bracket with this input. So there will be a side member and that is a bush which is in space. So we need to create an attachment bracket for that bush which is welded rigidly to the side member. So something like this, a two-piece bracket. So there are two pieces to this bracket which they'll be welded together, and then together they'll be welded onto the frame, and that will create the attachment point for the suspension, which is shown over here by these two holes in which the bush will go. So this is the final output in the assembly. So we are going to design this bracket. Let us see how to do that in CATIA. So let us come to the CATIA workspace, and this is Generative Shape Design workspace. This pink color part is the side member, and the cyan color part is the bush for which we need to design the bracket. So the first step is to create a plane. So let's go into wireframe, create a plane, and let's create a plane on this side face of this side member. So let's create an offset from plane, and offset is 0. Press OK. Let's start sketching over here. Give a normal to sketch, and let's start sketching the basic geometry of the bracket. So it should be something like this. Connect this point to this point. So making the basic geometry just to create a fill, and from there we will proceed. Just locate the points such that they get good coverage for the welding. So the longer this line is, the better the welding will be and the more rigid the attachment will be. Remove this unwanted constraint and this as well. Make sure this line and this line is coincident with this line on the frame, on the side member. So this line has to coincide with this line, or let's just project this and make a construction element. So this line has to be coincided with this coincidence. This line has to coincide with this. Press OK. Just tweak these points to tweak the geometry. It's easy to control the geometry by selecting the points and then manipulating them instead of the lines. So bring it over here. Let's keep this perpendicular to this line. So give a perpendicularity constraint to this as well. Let's keep these two as parallel, and let's keep this and this as parallel. So this is basic geometry. Make sure that the clearance between this edge of the bush and these lines are there. Enough is sufficient for the fillets. So let's just define them. Let's define it to be 15. Let's define this to be 17. So right now these are arbitrary values. Once we create the fill and then check the interfaces, then we can tweak these values. For now this should be enough just to start creating the surfaces. Now come out of the sketch. Make sure that the whole sketch is a closed profile. There are no overlapping lines because that will not create the fill. So there is a closed profile. Select fill command, select the closed profile and press OK. We'll get the first surface of the bracket. We can give the fillets also for these points. So go to operation, select corner, select this point for giving the fillet. Let's keep it at 38. Select this. keep it at 33. Selecting corner in operation and selecting these points. Zoom in. Let's give this as 54. Enter 54. Come out of the sketch. As you can make out, the butting surface of the bush is protruding out of the surface. So that means that we need to make another offset surface from this base surface and then create a bulge, something like this, which goes something like this. So for that, we need to sketch over here on this plane again. So go to sketch, orient the sketch so that it's convenient to work on it. And let's create something like this, a line like this. And give it a liberal fillet. Let's give it 110. And come out of the sketch. Create an extrude out of this. So create an extruded surface out of this sketch which we made. Press OK. Now create an offsetted surface of this base fill surface such that it matches this face. So what's the distance between these two? So let us measure that. Between this plane and between this face, it is 10 mm. So it is 10 mm, and let us keep 1 mm as the clearance between the end face of the bush and the end face of the bracket. So let us offset this surface by 11 mm outside. So let us create a plane which is 11 mm offset towards the outside. So minus 11 mm, create an offset plane of minus 11 mm offset. So here is the offset plane. And then just create offset of this. Go to surfaces, select offset, select the fill surface and create an offset equivalent to minus 11. And press OK. So the reason why we made this sketch and this extrude is to create a cut over here in this fill surface, and similarly create an offsetted cut on this offsetted surface so that we can blend them together. So let's see how to do that. Let's see that workflow. So first we will cut this portion, the bottom portion of this first fill surface, and press OK. Now the next thing to do is offset this extruded surface downward. Let's keep the offset as minus 15, and let us modify this extrude. Let us just right click and center graph to find out this extrude, and let us give the extrude on both the sides. Extend it either side so that we can cut this surface also with the bottom extrude. So this is the offsetted extrude surface of the base one, and now we can use that to cut the offsetted fill surface. So select this as the one to be cut and select this as the tool and retain the bottom side. So we retain the top side for the base fill surface, and over here we are retaining the bottom side, and press OK. Now hide the tools which I use for cutting, which is this one and this offsetted surface. As you can imagine, we can just blend this edge and this edge together to create that bulge. So go to blend. Before that we need to create two boundaries. So go to operations, create boundary, select this edge, hide the sketch, select this point and select this point. This is the boundary. Again select boundary, select this boundary, select this point and select this point. Make sure you're selecting the proper boundary and press OK. Now just blend it. Blend this curve to this. So in first curve, select the first boundary, and second curve, select the second boundary and press OK. We can improve this blend by giving the coupling points. So under these tabs, go under coupling, and under this there are 3 dots over here. Click on that and select this point. So this is the end point of this fillet which we had created. So let's zoom in. So this point, select this point, and then select the corresponding point on the other surface, which is this. So we created one coupling. Click at the bottom of that and select this first point and this point. So we created second coupling, and then press preview. So we'll see that it has smoothly joined. So you have improved the blend. Now let's join all of these surfaces into this join. So this join has all the 3 surfaces, split 1, split 2, and the blend. Now before we go ahead and give the fillets to these edges, let us modify this original sketch to give the fillets over here. So go to operation, go to corner in the sketch, select this. Let's give this as 20. And also select this point as, let's give it as 8. You can move this line a bit over here. You can increase this to, let's say, 12. Come out of the sketch. Next, let us give the edge fillets over here. So let us hide these boundaries. Go to edge fillet, select this and select this, these 2 edges. Let's give a value of 10 on either side. You can increase it to 15 also. So make sure that the end of the fillet is not riding on top of this, because that is the butting face of the bush. If you want to avoid that, we can just reduce the offset which we had given on the original extrude. So that was this offset. So we can reduce it to -13 to improve that clearance. You can keep it -11. So the blend will be modified accordingly, and we will have increased clearance. The next step is to create a symmetry of this surface on the opposite side of the side member. So for that we need a center plane. So to create a center plane, let us first find out the length of this bush. So the length is 90 mm. And this bush is located centrally with respect to the side member. So the offset on either side is the same. So if we take the center plane of the bush, we will get the center plane of the side member as well. So if it's 90 mm, then we can just take an offset from this face by -45. So this is the center plane. And now we will go to symmetry option. So go to symmetry. Select this surface, reference is this center plane, and then create the symmetry. Press OK. Next step is to create a blend between the opposing boundaries of the 2 surfaces. So the boundary starting from this point going all the way till here. So if you select the boundaries on either side and then blend them together, that will create the surface. So blend. Okay, before that, or we can create the boundary inside the blend itself. So inside this first curve, let us go to create boundary, right click and create boundary. So inside the blend option, if we right click, we will get the create boundary option. Select that option and create a boundary. Select this point to limit the boundary to these 2 limits. Press OK. Over here in second curve, right click, create boundary. Select this boundary, select this point and select this point, reverse the direction and press OK. So we have created the boundaries inbuilt into the blend command, and then just press OK. So that will create the blend. Now this surface has totally enclosed the bush inside the surface. But for practical assembly, we require a cutout so that the control arm which has this bush will be assembled from the bottom through the cutout. And also when the suspension articulates, that cutout will allow the suspension to articulate without any interference. So we need to give a cutout over here and remove these surfaces. So for that, we need to create one sketch on this plane and another sketch on this plane. And then remove this material or remove this surface over here so that we can get the cutout. So let's see how to do that. First, let us reduce this fillet because this fillet seems to be very high. Reduce it. Let's keep it at 25 and let's reduce this to 30. Let's keep it at 25. Just move this point, slide it up and come out of the sketch. Next, we will create a sketch on this plane. So whether we can directly sketch on it. Okay, we are not able to sketch on it directly. We have to create a plane with respect to two lines. Select this line and select this line and create a plane there and start sketching on that plane. Orient to sketch. Now create a geometry something like this to create that cutout. Make sure the endpoints of that profile are intersecting with these end lines or coinciding with them. Coincide this point with this line. Let's increase this. For now, let's keep it arbitrary. And then do the same thing over here. So go to plane, select this line and select this line and create a plane there and then sketch on that plane and make a similar geometry over there as well. Just orient to the plane. For that, let's hide the other planes to avoid the confusion. Hide this plane. Let's hide the older sketch as well. So let's sketch over here. Start from here, make something like this. This point has to coincide with this. Coincidence is okay. This point has to coincide with this line. Coincidence. Constraint, press OK. Again, keeping it arbitrary. We can modify this later on. Come out of the sketch. Now, this blend which we created, that we can basically split it into two portions. One is above this sketch and one is above this sketch. Go to the split option and select the blend and select this as the cutting element. Over here, let us select this option, keep both the sides, so that we can keep this side as well. We can later trim it using this sketch and press OK. So this is the split phi which has been split off, and this is the surface which has been retained, and that can be trimmed using the other sketch. So select this surface and select this sketch. Keep the top portion, press OK. Bring in the earlier section. So as you can see, the cutout has been provided. One more cutout which we require is the cutout on these two butting faces. So that cutout is for giving the fillet for this edge. So this edge we cannot give the fillet directly, because if we give the fillet, then it's going to ride on top of this line, and which is not going to create a good fillet, which will not be manufacturable. So for that, we need to create another sketch on this plane. And that sketch has to start from this point and end at this point. So start from here, create a perpendicular line to that line over there and create something like this. Create this kind of a profile, remove unwanted constraints. So this line, this point has to coincide with this point on this curve, on this sketch. So the endpoint of this sketch is the endpoint of this sketch as well. So make it coincide, coincidence, and this line has to be perpendicular to this line. Make it perpendicular. So relocate these points with respect to the fillets which were given. And make sure this point is coinciding with this point of the earlier sketch. Coincidence. Press OK. And this line has to be perpendicular to this line. Make it perpendicular. Let's give these fillets. Come out of the sketch and go to split option. Select this face, select this sketch. It will trim this portion off and press OK. Or we can create an extrude of this. You can create an extrude of this so that we can trim off the other side as well. So extrude, go to split command, select this face, select the extrude, press OK. We remove the bottom side. Go to split command, select this surface, select the extrude, we remove the bottom side. Press OK, hide the tool. So this is the geometry of the bracket which has been created. Next step is to join all of the surfaces and give the edge fillets. But before that, we need to cut down this blend which has been split into two portions. We need to cut it down into two halves because we need to create two brackets out of this surface. This surface will not be manufacturable in the traditional sheet metal stamping process. So we need to cut it into half and create two brackets which are welded together in a sub-assembly, and then that sub-assembly is welded to the frame completely over here throughout the periphery. So for that we need to trim these two bodies or these two surfaces into two halves and then join them separately with the surfaces on either side. So for that, let's go into the split command under operations, select this surface and select the cutting element as this plane. Make sure you are keeping both the sides and press OK. Again, go to split, select this surface, the second half of the blend, and select this plane. Keep both the sides and press OK. Now let's go into the join command and join the three surfaces on either side together. So go to join, select this surface and select this surface. Press OK. So this is one join. Then again go to join, select this surface and select this surface. Press OK. So we have two joined surfaces. One is this one, and another one is this one. So now we need to give the edge fillet on this edge. So go to edge fillet, select this. Let's give a 6 mm edge fillet. So this edge fillet on the frame is 9 mm. So you can go up to 8 mm. So let's give this a 7 mm. So when we give 7 mm, it's going to ride on top of this. So for that, we need to modify that sketch. Not this one, but this one. So just bring this up, increase this. So that should do it. So this sketch is constrained by this edge of the bush. So it should not intrude into this edge because the butting face is required for the bush. So this is the fillet which has been given 7 mm. Again do the same thing on this side, 7 mm. And the same 7 mm we can give it over here as well. 7 mm. And over here 7 mm. So these are the edge fillets which have been given. Now the next step is to create the thicken. So double click on part, create a body, define in work object, go to mechanical design, part design, select the thick surface option and thicken it outward with, let's say, 2.8 mm thickness. Again go to part, insert body and go to thick surface, select the other side and thicken this 2.8. So let's hide all the other bodies. Let's only visualize these brackets. Here we can give these fillets as well. So right click, define in work object, go to fillet, select this, let's keep it at 5. Select this as well. It's okay. Along with this, you can select this also. You can do it the same on the other side. Define in work object, go to edge fillet. Select this edge, control select this edge, then this edge, then this edge, then this and this. So these are the two brackets which will be welded over here and over here, and together they'll be welded on top of the frame over here around this periphery. For fastening, we'll require to create one hole on either side of the bracket, which can be easily done by projecting the hole of the bush and just creating that hole. So this is the workflow of creating such a bracket. Some of the sketches were left unconstrained, that is to have the freedom in design to just tweak the design as and when required. We can create the constraints based on the issues which arrive during the design.